Good afternoon, everybody. Welcome to our third installment of Nuclear Science Week webinars. My name is Adam Trider, and I am the lead of the Center of Excellence for Energy. I wanted to take a moment to thank everyone for joining us this afternoon. And big thank you to our partners, Atlantica Center for Energy, NB Power, Moltex Energy, and ARC Clean Energy Canada for being here this afternoon. We are very excited to present a series of webinars this week during Nuclear Science Week. Which is a broadly observed celebration that focuses on building interest in education on all aspects of nuclear science. Each day this week provides opportunities for learning about the contributions, innovations, and opportunities that can be found by exploring nuclear science. And each day we'll have scheduled webinars for students and guests to join in. And on the final day, we'll be giving students a chance to test their knowledge by joining us in a game of Kahoot, and prizes are available. We're very pleased this afternoon to have the Honorable Mike Holland, Minister of Natural Resources and Energy Development, on the call. And I'll give the Minister a few minutes to bring greetings this afternoon. Minister Holland.
I have to master the mute button first. I appreciate that very much. It's a pleasure to be here in an educational environment. Putting ourselves out there to answer questions and have conversations about the exciting opportunities that small modular reactors play for the future of not only the province, but of the entire planet. I have served in this role for about the last 30 years, and I've been very excited to say that the small modular reactor file has played a huge role in the work we've done in the energy department. We've gotten to know a couple of companies here in New Brunswick who are leading the charge on a worldwide front to make New Brunswick a leader. This is something that when we talk to students, I get quite proud of, because the students, the next generation that's coming up, are going to have a chance to benefit from this sector as we grow it and develop it. I'm looking forward to hearing about a time when this is just a normal area where people look towards starting a career and building a life around their life here in New Brunswick. The work's being done now to lay that groundwork so that students have an exciting option as it relates to small modular reactor technology going forward. You know, it plays an important role as we talk about creating opportunities for people to work and live here in New Brunswick. But on a larger scale, it creates a massive opportunity for us all to be involved in a project that decarbonizes the atmosphere, that creates a source of electricity that is non-emitting. And when you combine those two aspects, we're dealing with something where people can make careers and make a difference at the same time. So it's a pleasure to be here. To whatever limited knowledge I have, I'd certainly love to contribute. And it is a privilege to be here with the companies that are making a mark on the future of the province of New Brunswick, and to be here with the students. And I'm just available for anything that I can offer. So thank you very much, Adam. I appreciate the time.
Thank you, Mr. Minister. Appreciate you being here this afternoon. Now I will turn the mic and camera over to Alex Woodward from NB Power to bring some greetings and introduce our speakers.
Thank you, Adam, and thank you, Minister Holland, for those words. Welcome. My name is Alex Woodworth, and I work for NB Power on the Advanced Reactor Development Team. We are speaking to you today from New Brunswick, the traditional territory of the Mi'kmaq, Wolastoqey, and Pescatawagati. In this session, we will be joined by Claire Harris, the Manager of Environment and Engagement at NB Power, Rory O'Sullivan, the Chief Executive Officer at Moltex Energy, and Bill Lappy, the President and Chief Executive Officer at ARC Clean Energy Canada, to discuss the next generation of nuclear technology small modular reactors. So Claire, Bill, and Rory are really eager to hear from everyone today and answer any questions that you might have. So I will get us started and hand it over to Claire.
Thank you, Alex. Can everyone hear me okay? Yes, thumbs up. All right, my name is Claire Harris, and I work with New Brunswick Power on the Advanced Reactor Development Team. I graduated from Miramichi Valley High School in 1985. So shout out to Miramichi Valley High and all the teachers and the students there. And my sons graduated from Rossay High, and so shout out to Rossay High. After I graduated from Miramichi Valley High, I went to NBCC and I studied power engineering technology. And then I continued on to get an undergrad degree and with a focus on environmental management. So energy and environment matter greatly to me. And I've really focused most of my career on those two aspects. I've been following the climate change conversation for many, many years. And in fact, in 2007, I read a book by James Lovelock entitled The Vanishing Face of Gaia. And so that was back in 2007, that's 14 years ago. And I've been following the conversation. And when I heard that New Brunswick Power was starting to work with advanced nuclear reactors, I raised my hand and said, please let me help. I'd love to work on this file. And so I've been very lucky to have been able to work with two wonderful companies, Moltex Clean Energy and ARC Clean Energy, and I'll continue to support in any way that I can. I think the key thing that I'd like to make sure that we all understand is that we need all the tools in our toolbox for a clean energy future. And so, the advanced reactor program is not in competition with the renewable program. We want all of the tools in our toolbox. We need wind and solar and hydro and battery storage, and we need advanced reactor program. And so as we work together for a clean energy future, I believe that we need to make sure that we understand and continue to come back to the fact that it's all about collaboration. And it's not about competition, it's about collaboration. And we see this with Moltex and ARC. It's, they demonstrate collaboration for us, and they show us just how collaboration can be done. And so when New Brunswick Power started to look at the advanced reactor program and our energy future, our clean energy future, our scientists and engineers looked at over 100 different designs. And we landed on ARC Clean Energy and Moltex Energy as the two designs that we wanted to work with, the two companies that we wanted to work with. And so I'm really pleased to turn over to ARC and Moltex today so that they can talk about their plans for the advanced reactor program. And I hope that you ask them some really tough questions. I'll lob them all over their way. But I'm really interested in hearing from as many students and teachers as possible in this period of time. I'm curious to know what your concerns are and what your questions are as we continue to build a clean energy future. So I'm going to turn over and thank you for your time and attention, and look forward to hearing from many of you and also meeting you in the future, so that whenever we talk about nuclear in the future, some of you will come out to our events. So who am I turning over to, Rory or Bill? Who's next? Bill, you're up and off mute. Great.
Yeah, that'll be great.
Thank you.
Yeah, thanks, Claire. And so, no, we do appreciate the opportunity to speak to this group. We're really excited about engaging high school and other ages classrooms as you move through your middle school and your high school learning opportunities. And just a little bit about myself, a little bit older than Claire, went to, graduated a little bit ahead of her, but the classes that I enjoyed the most were physics and math. They were a lot of fun, and I kind of saw physics as applied math. And if you engage in those, perhaps an engineering field could be in your future. But I went through school enjoying physics and math and got into mechanical engineering. I graduated with a mechanical engineering degree, and then moved into a master's in management as a master's degree. And it's as you look at your opportunity for school, where do you go post high school? engineering is a great way to get into this industry. So it's a pretty exciting opportunity, and it can lead you into many different aspects of the industry. And one way to think about that is perhaps you get into engineering, and then that can lead you into different parts of power plant and what this sector has to offer. Some of it is engineering. There's a lot of calculations, there's a lot of drawings, there's a lot of technical specifications that have to be put together, and that's a part of the industry that is very exciting and can lead you in many different directions. I did a piece of that for a while. I started my career in oil and gas and worked in refineries around the world. So it was in the Middle East, I was in the Far East, came back to the US, worked in a refinery down in Puerto Rico, and then elected to see what other opportunities could come from that. And I got into power generation. So I've had a long career working in and around power plants. And the other part I spent a bit of time is working on the electric grid. While as a mechanical engineer, the electric grid has a lot of electrical engineers. And I was fortunate enough to work with a few thousand electrical engineers and learned a lot from them. But as you get into power plants, my career brought me through different parts of power plants operation. So while I was an engineer, I spent a lot of time running the facility. So it was at least 15 years. There's a lot of training that is involved. So while you come from school with a BS degree in engineering, you may find yourself in a classroom for many months just to go through training and to be qualified to operate the facility. So I did that for about 15 years, and then I spent a number of years after that what I would call care and feeding of the facility. So there's a lot of maintenance that needs to be done, work management, and then these facilities need to be refueled. So there's a lot of work that gets done in refueling. So while you look at where your career might go, you will find it very interesting and a lot of different opportunities of where that may take you. A little bit about ARC, and maybe I'll just share a picture of it. It might be helpful. And perhaps I won't be able to share my screen. But ARC is a 100 megawatt unit. It's a pool reactor. It's known as a sodium fast breeder reactor. The fast breeder reactor part of it is we control the speed of splitting the neutrons and how much time that neutron sits at a high energy state. And so that's a fast neutron. There are neutrons that are slow neutrons, and that's what Point La Pro has, is a slow neutron, and it's called a thermal neutron. But that reaction of splitting a neutron into pieces, other neutron reactions occur, and that's where you get a lot of heat. And so that heat, that chemical energy transitions into thermal energy, and that's what you see here in this little picture. This pool in the middle is the pool reactor. It's the primary sodium loop, and then this column in the middle is what we would call a steam generator. That's where that thermal energy is transferred to mechanical energy, and that flows through this what we call a turbine and then a condenser, and then it turns that steam back into water. That water gets brought through this loop again. You can just see this is what we would call a closed loop system with this pump. Then it connects through this electrical generator to the grid. It powers the grid. As I mentioned, it's 100 megawatts. And then what does that mean for scale? So 1 megawatt would be enough energy to power homes for 10,000 houses. So that's relative size. You get a lot of energy. There's a lot of density in this facility. It's a very dense power output, different than other sources of power that are a little bit more spread out. And a way to think about that may be a wind generation, where towers of those windmills are in different locations, and it's a little bit further apart. But the other piece to be aware of is that we use a fuel that's enriched. And what do we mean by that? That enrichment is in the ground. You'll find naturally occurring uranium. We take that uranium and we concentrate it a little bit, if you will. And then that's what you see is where that fuel assembly sits in what is called a core, and that's where that heat is produced. That's how that energy is transmitted to this intermediate loop. But it's a little bit, I will stop sharing now, but that's a picture of what the power facility looks like. We used enriched fuel. That fuel lasts for 20 years. And then what essentially happens is we come in, take those fuel assemblies out, we'll put in new fuel assemblies, and then we'll run that facility for another 20 years. So it's got a lot of power density to it. It's got a lot of life to that fuel. And then one of the things that we like about the ARC unit has been described by the Energy Minister and Claire is that it pulls greenhouse gases off the grid. And what we mean by that is that we're not burning a fossil fuel, and so that we can, clean the grid with a clean fuel source and not have greenhouse gases generated. And then the last piece I'll say is that we think of our facility as either it has a grid interconnect or it has steam that can be used for other purposes, and that steam can be used for industrial use. Think of it as making a fuel source, a clean fuel source, and that clean fuel source could be used for other purposes. And so that way you've got opportunity for other manufacturing processes to be used. And so, Claire, I think I'll stop there and we'll let Rory share a little bit, and then we can answer some questions.
Thank you.
Thank you, Bill. Thanks, Claire. So hello, everyone. Like the others said, it's really an honor to be here. High school is the time where you decide what you're going to do with your future. And I say that like it's a lot of pressure, because basically it is. When I was your age, I really didn't have a clue what I was going to do. Absolutely no idea. But I was kind of not terrible at math. So I ended up going into a very general engineering course, because that's just kind of what I ended up doing. I then specialized in mechanical engineering in Trinity College Dublin in Ireland. I studied in France for a while too. But engineering is a really good platform for doing lots of different things. You can really, from any engineering discipline, you can really get into a lot of different sectors. Obviously, nuclear is the most exciting one going on today. But when I graduated with a mechanical engineering degree, I actually graduated anti-nuclear. I was anti-nuclear because of the high cost of nuclear power, because of the safety performance and the long-lived waste that comes out of it. But I was very passionate about energy. So I did a summer internship. I spent about 3 months working on a wind farm, developing wind turbines on the west coast of Ireland. And I pretty quickly saw there that although renewables can have a role in decarbonizing the grid, they're really just not going to solve all our problems. And I saw the amount of land that was being used by turbines, the fact that they're only on part of the day when the wind blows, there really needed to be something else. So because I saw there wasn't a future for renewables, I was anti-nuclear, I went off into a different industry and worked in construction and project management for 10 years or so. And it was really only when I came across this new class of nuclear power, small modular reactors, and in particular liquid fuel reactors, I realized maybe there is a future for nuclear. This type of nuclear actually had the potential to be low cost, had the potential to be extremely safe, and had the potential to deal with nuclear waste. So I spent a couple of years studying at night, doing a lot of research, learning about nuclear physics. And then I came across, I met the inventor of the Multex technology. This is in 2014. He had just came up with the idea of our reactor. And I was obsessed. I knew this was the future. So it was just after that in 2015 when I joined Multex, and we kind of set up a company from there. This was in the UK, where I was living at the time. And we were looking at all of the different countries that would be best to deploy this technology. And Canada came to the top of the list for quite a few reasons. It's a very aggressive targets for clean energy. It has a market, so it needs new power, and there are customers who want, you know, more electricity, more energy on the grid. But kind of probably most importantly, it has a very good innovative regulatory environment for innovation in nuclear. And that seems like an easy thing, but in other countries, it would take years, even decades, to change regulation to be able to do nuclear. So that's when we started looking at Canada. And then when we started working here, we came across NB Power, and NB Power were doing this technology selection and selected us, which we were really excited about. NB Power was looking for a presence in New Brunswick. We were looking to move to Canada, so it was a really good fit. So that was 2018 when I moved to New Brunswick, and we set up Multex Energy Canada, and I lead the North American activities here because we have people and work going on in the US as well, all led out from the New Brunswick office. That's kind of the high level history of where we are today. But the technology itself, so I mentioned it has some of those attributes that differentiate it from conventional nuclear. But what excites me is the potential for it to recycle existing nuclear waste. So nuclear waste, it's produced with any nuclear power station. We today know how to safely manage and store it, and there is a plan for that to be safely stored in the future. But it's socially not really accepted. It's the real Achilles heel of nuclear power. So with the invention that we came up, the stable salt reactor, we're actually able to take the existing waste that's currently stored at existing reactor sites across Canada and around the world, and we can convert that into a new form that we can put into our reactor and use it as fuel. So instead of getting more uranium from the ground and mining fresh fuel, we can just use the waste. And instead of putting that waste underground for hundreds of thousands of years, we can create more clean energy from what was waste. So that really excites me. That's what we're doing right here in New Brunswick. And it's getting a lot of traction. The amount of waste around the world could power 100,000 megawatts worth of our reactors for 60 years. So put it in context, the Point Lepreau reactor is 600 megawatts, which is a pretty big power station. Well, with all of the waste around the world, we could have 100,000 megawatts of power plants. So that's what's that? That's a lot of Point Lepreaus. We could build 20 of our reactors across Canada, and we're looking at building a 300 megawatt reactor in New Brunswick. So very exciting times. There's a lot of opportunity, and looking forward to some questions and having a chat. Thank you.
Thank you, Rory. I think we turn over now to Alex and Adam to moderate the questions. Is that correct?
That's right. As everyone has just heard from our speakers, they're really eager to answer any questions that you might have about SMRs. So if you do have any questions, feel free to enter them into the chat and we can hand them over.
I've got a question while we're waiting for folks to maybe start typing into the chat. Rory, you mentioned that you're looking to build a 300 megawatt reactor in New Brunswick, but what are some of the other markets you're looking at for your reactor? And then I'll ask the same question to Bill here in a minute as well.
Yeah, thanks, Adam. A good question. So we are a bit of a special case because we're focusing on spent fuel. We're really focusing on markets or customers like utilities, like NB Power, that have an existing waste issue, that have stockpiles of waste that they don't know what to do with. So, of course, the first market is New Brunswick here, where there's a lot of waste at Point Lepreau that we want to turn into energy. The next one in Canada is Ontario. 90% of Canada's waste is Ontario, owned by Ontario Power Generation. Some of it comes from Bruce Power. So that's the next target for us after New Brunswick. Quebec has a small amount as well because they used to have a reactor that they've shut down now. But then the next biggest market is the United States. The United States have 25% of global spent fuel stockpiles, because they're the biggest nuclear power nation. And after that, it's other countries that have had big nuclear programs, like France, the UK. China has just got a new nuclear program, so they don't have as much legacy waste. It's the ones that have had nuclear power for a long time.
Okay, great, thank you. Bill, I'll throw the same question at you. Are you looking at the same areas, or is your reactor going to different places?
Similar approach, I guess I would describe it. We believe there's a great opportunity for a number of units here in the province. It's a 100 megawatt unit, and we look to put 4 of those at La Pro. And then on the there are other parts of the province that would interconnect well with the grid that probably warrant another 4, most likely on the north shore of the province. And then we're doing a little bit of a look about where, if we did some non-grid units, if we were looking to do industrial use, there's probably another 4 or 5 in the province. So in our timeline from 2030 to 2040, there's a number that could be built on the grid and off the grid, for the industrial use. And then similarly, there's a couple provinces across Canada, Alberta, Saskatchewan, for different reasons. Saskatchewan to green the grid, get some of the greenhouse gases that they have off. And then in Alberta's a little bit different. They have an oil sands industrial use. This unit produces steam at high temperature, high pressure, and that helps get the oil sands out. So we believe that's a good opportunity to use it in greening that industrial process. So that's kind of the Canada approach. And then US market, I agree with Rory, is a good opportunity. There's a lot of retiring coal units that need to come off the grid pretty quickly. In relative terms for energy space, quickly is in the next 10 to 15 years. And then what I would call the growing market after that would be Europe, perhaps Eastern Europe, as a similar sort of situation where they have old coal units that need to be replaced, or even some gas units that make sense from a geography. But it's globally what needs to be done. We do need to get fossil fuel burning out of the electric sector, and then there are other industrial uses that are need to be done also. So transportation, industrial use, all need to continue to move forward in a green sort of way.
Thank you. I see we have a question in the chat, and maybe I'll throw this one to Claire, see if you want to tackle this one. It says, I'm curious, that's from Paul McNutt in Anglophone South. I'm curious if either of the SMR designs offer the potential to produce medical isotopes.
And as promised, I said I would send my questions over to the to Moltex and ARC. I don't believe, but I'm going to leave it to Moltex and ARC to talk about medical isotopes. I know we looked at the feasibility of doing it at Point Lepreau, and it's really not a feasible process right now for the Point Lepreau nuclear generating station to produce medical isotopes at this time. But Bill, maybe I'll get you to start. Is it a potential at all for your type of reactor? And then I'll get you to turn it to Rory. Yeah,
it is. Yeah, thanks for the opportunity. I think it works well with a fast neutron. It's a little bit different isotope that we would look to use, and I think it fits well in our deployment of these reactors. So I do believe it's a good opportunity.
Yeah, and Rory here, we absolutely can. The reactor is very capable of doing it. We've designed it to be able to put in different samples to be able to irradiate a wide range of materials or medical isotopes. When we looked at it about a year or two ago, it wasn't really clear where the market would be, which isotopes are really needed. So what we've done is sort of made a flexible design so that when we get closer to construction, we could do some modifications to suit whatever the medical isotopes are needed at the time. And similarly, you know, if we have another reactor in Ontario after here, you could configure it slightly differently to have a different isotope. So it's a really important market. Canada is a world leader in this, so we want to be ready, and are ready to support the needs of the medical industry.
Great, and thank you for your answers. I have learned something today, which is always a good day, and I'll definitely note that for future. Thank you.
Awesome, thank you. We have another question in the chat, and it is, what type of careers are there for students to explore in the nuclear industry besides engineering?
Well, Rory, you want to go first, and I can add to that?
Sure, yeah. So it really varies depending on what stage the project is at and what's going on. So there's kind of three big classes of jobs. There's the jobs that we're leading now, that this is, I'm going to speak for Bill, but when we're designing the reactor, we've mostly got engineers and people who can design. It's not exclusively, there's other you know, engagement, communication, there's lots of, and finance, there's lots of commercial jobs there, but it's a 90% engineers and technical. After that, as you get into construction, we'll need every sort of job relating to construction. So that's your regular form work, all of your trades, steel work, welding. And then there's the manufacturing. So if you think the way these things work is there's, you know, maybe 1,000 different components that are needed to build a power plant, or more than that, and they're typically made in different factories around the world. We're trying to get as much of that done in New Brunswick as possible, and so that's typically technical trades roles, a lot of welders, manufacturers. They supply the components to the construction sites where it's all put together, and it'll grow and grow over time as we get into construction and build many of these around the world. Bill, anything to add there?
Yeah, no, I just add a little bit. You know, I think you described it well. Engineering, there's, you know, the manufacturing process will require, you know, a lot of good talent. The construction, building trades, all of the building trades, you know, electricians and millwrights and carpenters and equipment operators. So, you know, I think the community colleges is a really has really good programs, and we will continue to engage with community colleges. So I really do encourage that look if you're considering it. And then in the fleet services, we will look to run, you know, multiple power plants, and we'll do some analytics around those power plants. And so, you know, some thought around, you know, how we can best optimize the running of the facilities. So there is just a plethora of opportunities for young professionals to join in many different ways.
Thank you both. And also, let's not forget the environmental scientists and the sociologists that will be, you know, looking at the studies around, you know, where we deploy these in the future. And so, you know, from an environmental point of view, I think environment is going to really drive us towards a clean energy future. And so, yeah, that's also an area that I think we're going to see some growth in also when it comes to the advanced reactor program.
Thank you. There's two other questions in the chat, but they're both related to safety. So maybe we'll start with how do you make sure SMRs are safe, and are there any safety risks involved with these new nuclear reactors?
Bill, we swap around. Do you want to kick this one off?
Sure. So, no, that's a good question. One of the things that we will do as part of our analysis of the facility is a safety assessment, and that safety assessment goes through multiple reviews. We will do it as a company. We'll have independent companies do that safety review, and then ultimately that review will go to the regulator. So we will call it a final safety assessment report. So there's a PSAR and an FSAR, but those documents look at all scenarios in which an event could occur, and then they look at the way that the system is structured to mitigate those events. And so that's part of the review process that they will take. And until they are convinced that they believe everything is in order, after that is done, then they will give approval. But until they are comfortable with that design, that's the process by which it is undertaken.
Thanks, Bill. And just kind of coming back here, rather just jumping in straight into our technology, I just wanted to remind people that today's nuclear power is one of the safest sources of energy available. Nuclear power is responsible for fewer deaths per unit of electricity than any other source. Coal, of course, is the highest by far because of air pollution, but nuclear energy even today has an impeccable safety record. So our plan is to even improve that, get this very high bar even further, and we do that slightly different ways to conventional reactors. But as Bill said, building on the analysis we have to do moving forward, we've completed phase 1 of the Canadian Nuclear Regulators review process. We have phase 2 to go, and then an even more comprehensive licensing process led by NB Power. And to put it in context, phase 1 is the light, easy process, and we've submitted about 1,000 pages of documentation, maybe even more when you add everything up together. But there's a lot of review being done, and there'll be a lot more to go. So there's really no stone left unturned when we get these up and running.
Great, thank you. And thank you, Rory, for pointing out that, our existing nuclear power plant has an impeccable safety record. So it's important to note that and really kind of keep that in the back of our mind. And the idea that, that design was, I guess maybe designed back in the 70s, and we're talking about a 2021 design, right? Or 2020 design that we're building on. So it's really, it's been a consistent focus for the advanced reactor program to design away those safety concerns, or at least consider in the design what are the safety concerns and how do we make sure that we address those at the onset of the design.
Another question in the chat. Why do we need to build more nuclear? Why can't we continue to build renewables to mitigate climate change?
Rory, would you like to take that one to start?
Sure, yeah.
All right.
Yeah, it's this question that gets asked quite a lot, and there's an awful lot of people that say we don't need any nuclear. The challenge is, if we want to get to carbon-free economy, I have yet to see any credible study that demonstrates that we can get to carbon-free without nuclear power. There are some people saying we can do 100% renewables. The only scenario that will work is if there's some miracles in terms of new technology, new battery storage that'll break the laws of physics, or we have extremely expensive electricity, 10 times the price of what we have today. So if we don't want electricity price that's 10 times more, and we want stable, reliable electricity and energy on the grid, you absolutely need nuclear to fill the gap with renewables. Solar and wind only operate 30 to 40% of the time. So although they're great and have a really important role to play, they are not going to solve all of our problems. You need a combination of renewables and nuclear to get that reliable energy all year round, when it's really hot in the summer and we need air conditioning, and when it's really cold in the winter and we need our heating up full blast.
Well said. Bill, did you want to add to that?
Yeah, no, I think Rory articulated very well. That's those other sources, hydro, solar, wind, are all good. We need those to be part of the energy mix. And then if you look at the grid in those studies Rory was talking about, in order to supply that electricity to everybody's home every day of the week, 24 hours a day for around the year, that can happen with what we call those base loaded units. And that's what the SMR's technologies provide, as a base load unit. It's part of that mix. And when you put it all together, that's how we get a reliable supply of electricity.
There's an example I like to give to demonstrate why batteries are not going to solve our problems in the near future. The largest battery on the grid, and batteries on the grid, essentially, you have solar and wind that are producing electricity. If they produce too much when the wind's blowing a lot and the sun is blowing at the same time, that electricity gets stored in a very large battery on the grid. So if you think of the Tesla battery packs, there are small battery packs that are in each home. So that's the alternative. You have little batteries everywhere or big batteries on the grid. And this is what people are saying can be mixed with renewables to give us reliable power. The problem is the largest battery in the world today that's still under construction can produce the same amount of energy as an average size nuclear power plant for 20 minutes. The wind doesn't stop for 20 minutes. The wind can stop for days or even a week. So to turn the size of that battery, that's like, many hockey rinks, to do 20 minutes is just so far away from being viable as a large scale solution to our energy problems.
Thank you. It's great. It's a great example.
I see that we've got another question in the chat. It says, how long will it take for an SMR to provide clean electricity to our grid when renewables are offline? I think it's trying to capture about the connectivity between renewables and the SMRs. Is it something instantaneous that when the wind dies down, we can just flip a switch and have that SMR come online, or is there a lag?
Yeah, I'll try this and then Rory can jump in too. So we call it's a pretty dynamic grid. It's there's load that's changing every hour on the day. So there's more load in the morning, and then there's a valley, and then there's more load at night. So we call two peaks on this grid. So that source is really moving around, and the load is moving around. And then there are ways that the grid operator, the person controlling the grid, can manipulate sources of generation so that they complement each other. The way that the way the ARC unit is going to be structured, that if there's we're producing 100 megawatts, and that there's an opportunity for sun and solar to be on the grid, and we need to take 20 of those megawatts off, we can take that 20 megawatts off, we'll put it into storage, and then later in the afternoon when the sun starts to set and we need those 20 megawatts now, then we can pull it back onto the grid. So there are tools that we can use to make the system efficient while not cycling units around up and down, so that we can still produce a lot of energy in a clean sort of way.
And what we've designed into our power plant is the combining heat storage, thermal energy storage with the nuclear power plant. So the examples I gave earlier were about battery storage, storing electricity, which is intrinsically very, very difficult. But all of a sudden, what's new about these reactors is they produce high temperature heat without any carbon. So carbon-free high temperature heat. So it's actually very easy to store large amounts of heat. We do that in large tanks of molten salt. If you there's another in the renewable sector, there's a concentrated solar power sector where they have loads of mirrors in a desert. The mirrors reflect the sun to heat a molten salt in a tower in the middle. There's pretty cool photos online if you Google concentrated solar power plants. What they do is they heat that salt in the middle and store the salt so they can have constant electricity when the sun's not shining. We do the opposite. We've got constant hot liquid salt coming out of the nuclear reactor all the time. We store that in these big tanks, and then whenever the grid needs it, we can use that heat to produce flexible electricity onto the grid. And I say molten salt a few times there. Essentially, if you take table salt and you heat it up to about 400 degrees, it turns into a liquid. It flows just like water, really good for storing heat and moving heat around. And there's thousands of different types of molten salts that we can use. We use different ones in the reactor to the storage. There's a lot of different applications of it.
Awesome. Another question in the chat from the Anglophone School District in the East. My students are looking for recommendations on post-secondary institutes for engineering, preferably in Canada. Any recommendations from the panel?
I would highly recommend University of New Brunswick, Center of Nuclear Energy Research, and I think that Dr. Willie Cook is going to be here later in the week. Is that correct, Adam and Alex?
That's correct. He will be speaking with us on Thursday.
Yes, so highly recommend that you look into those programs. And I believe that the number of students is growing every year since the Advanced Reactor Program has come into play. And maybe Rory and Bill, have you more to add to that?
I agree, Claire. The universities in New Brunswick are all very good. And then the program that Dr. Willie Cook is running is outstanding. So we have a number of UMB graduates right here. So they are very talented, very capable, and we appreciate everything that they're doing.
Yeah, we have a few UNB grads too, and really great course, so that's highly recommended. The other big nuclear programs, just tailoring the response to nuclear programs in Canada, are some of the big universities. McMaster have a nuclear reactor on campus. So they do a lot of research there, and they have a big nuclear program. The others, University of Waterloo is a big one for all engineering, but they do great nuclear programs too. And then McGill have some good nuclear programs. There's many others, but they're probably the biggest in Canada.
Yeah.
Great, thank you.
Thank you for that answer. Another question from the chat from Paul McNutt is the potential to recycle spent fuel as SMR fuel is very appealing. What sort of risk is associated with reprocessing already radioactive spent fuel bundles?
I guess that's probably for me. Yeah, great question. There are definitely risks with this. This is by no means risk free. Nothing really is. The spent fuel that's there is very radioactive, so we wouldn't be contemplating any humans holding it. It's all done with robotics, so it's all automated. It's all shielded behind big, thick concrete walls. So our facility that'll convert the waste into fuel for our reactor, essentially it'll be in a giant concrete box where the walls are about 1 meter thick, and that keeps any humans or operators at a safe distance from the radiation from the spent fuel. Because spent fuel, when it comes out, it goes into a reactor, is not radioactive. After it's been through the reactor, when it comes out the other side, that's when it is highly radioactive and hazardous. So that's one of the risks, one of the things we do. They're also dealing with spent fuel has special regulations. So obviously the Canadian nuclear regulator is very involved with what we're doing today, and they'll be overseeing everything. There's also an international regulator called the International Atomic Energy Agency. It's a coalition of different countries, a body of the United Nations that will also be overseeing all the work that we do. So this is very high profile work. There's a lot of surveillance, there's a lot of analysis, and there's various regulators that'll be overseeing what we're doing to ensure it all goes safely and without any hazard, minimizing the hazard.
Thank you, Rory. When the waste comes out of the Moltex reactor, how radioactive is it then? Is it still highly hazardous?
Yeah, it's actually intrinsic to the nuclear fission process. So once you have nuclear fission, the spent fuel will have the same amount of radiation off it, depending on the amount of energy that's being produced from that unit of fuel. The difference because we've got this recycling technology, we take the spent fuel out of our reactor and then put it back into the process again. And it's essentially a loop where we take the radioactive spent fuel out of our reactor, put it back in, and we can keep recycling it around and around and around for 60 years approximately, so that we can get all of the long-lived waste at Point Lepreau. We can use all of that to produce its energy. We can't get rid of everything at the end of the 60 years, but we can significantly reduce the quantity of spent fuel that was there, of long-lived spent fuel particularly.
Right. And after that, it would still have to go back into some kind of long-term storage? Or?
So after that, the amount of the reduced amount of long-lived waste can either go back into another reactor, and you can keep recycling that again. You can do it over again to reduce it down even further, and that process is essentially infinite. You could that long-lived waste you can keep taking, reactor to reactor to get more and more out of it until it's gone. There's still there's still now another volume of intermediate or low-level waste is called. So the long-lived waste is the one we're really focusing on to really reduce that down. But there'll always be low and intermediate level waste that we'll have to dispose of. But that's much safer to handle and dispose of, and it's not around for that kind of hundreds of thousands of years. It's around for much shorter periods that we know how to dispose of safely.
Thank you. And Bill, will your waste from the ARC 1000 reactor, will that feed Moltex's reactors someday, or is there?
Hopefully that's what we want. We want all the waste.
Perhaps there's potential, yes.
All right, folks, the chat has gone quiet the last couple of minutes. Maybe I'll do a last call for questions here from those folks in the audience who might want to ask a question of Rory or Bill or Claire this afternoon.
While we're just doing that, Adam, I might just, there's one point I wanted to make today, which is just to reiterate the role of nuclear and remind people how it fits into the decarbonization picture, because I'd say most people, and actually this is a few years ago, statistically in Canada, it was the majority of people in Canada thought nuclear power contributed to climate change and made it worse. So just wanted to reiterate, nuclear power, like renewables, is carbon free. You know, it is doesn't produce carbon, so it does help with climate change and reducing carbon. I mean, that sounds obvious, but statistically it's not. But comparing it to some of the other sectors, so this is including manufacturing, construction, transportation, and decommissioning. And nuclear power produces about the same carbon as wind turbines. This is per amount of electricity produced. They produce about a third as much as solar, 30 times less than gas, and 60 times less than coal. So, that shows that coal is obviously the worst for climate, producing the most carbon. Gas is about half as good. And although solar is a little worse than wind and nuclear, it's still all relatively close to zero compared to gas or coal. So just wanted to remind people how important it is that nuclear really is the same as renewables for climate change.
Thank you. I see we have a new question, Adam. There you are.
Yep, another one has dropped into the chat. It says, do you offer co-op placements or other experiential learning opportunities for high school students?
Bill, we haven't done that for high school students yet. We're looking at doing it for the universities, during the summer break or during holidays. That would be our first approach. And then perhaps it'll be something that we consider in the future, but we're currently not doing it today.
How about Moltex, Rory?
Yeah, so we have co-op students, and we have a commitment to take 50 co-op placements over the next 3.5 to 4 years. We haven't explored taking co-op high school students. We can go away and have a look at that, but at the moment that was not not part of the plan. It was co-op students that are typically in a field of post-secondary education already, but we'll go away and have a look and consider it.
How about at NB Power, Claire? Are you familiar with any high school co-op students?
I'm not, but I'm sure that our human resources department would be the right people to ask. But Adam will definitely connect back with the Center of Excellence for Energy and NB Power just to see what that looks like. And I believe it's an area that we'll be working with you on to consider going forward how we're going to do that. I know that we've done a tour with some students or in the past few months, and there was a huge amount of interest. And so I think co-op opportunities and more opportunities to talk about what we do. And the energy sector is key for the future. But we'll work with you.
Absolutely. Yeah, and I'm aware of one actually right now, working with the Emerging Technology Group. She's got an interest in graphic design and is working currently with Dan Kane in that field. So
Nice.
yeah, it's exciting. So if there's students on the call that are interested in co-op placements at NB Power, check out the Center of Excellence website.
Yes,
Let
thank
me
you.
know. Send me a message.
Exactly. We'll work with you. Perfect. Are you going to come back to us, Adam? Alex?
You get me.
I'm good. That's awesome. Thank you. All right.
Well, if we don't have any other questions, I just wanted to thank everyone so much for their time here today. And thank you again to our speakers for taking the time to chat with us today about SMRs. Adam, did you have any last words you wanted to add before we wrap up?
No, just to reiterate Alex's words there. Thank you so much, Bill and Rory and Claire, for being with us this afternoon. It's very exciting to see this come together after many months of conversations, and really looking forward to growing these opportunities for our students in the future. So thanks again for being here this afternoon.
And
Thank you,
I
thank
see
you, Alex.
Minister Holland is still on the line, so thank you also, Minister Holland, for being with us for the time. Thank you.
Bye, guys.
My pleasure.
Thank you.
Very exciting.
Have a good day. Bye-bye.
Thank you.
Bye.
Bye.